Hello everyone, you are learning with Dr. Shobha Nikam. In this video, I'll talk about types of optical fibers. In case of optical fiber communication, sources are LEDs or lasers, and at the receiver end, we use photodiodes, avalanche photodiode or pin diode for reception of the light. But we send information over optical fibers. You know the structure of optical fiber, it has core, it has cladding, and they are made up of either pure silica, that is glass, or they are made up of plastic material. So today we will differentiate different types of optical fibers and we will also discuss their applications. So optical fibers are divided based on operating modes. Operating modes means how many wavelengths can pass through optical fiber at a time. So single mode fibers and multi-mode fibers. In single mode fiber, only one ray of light can travel at a time, or only one wavelength can travel. Whereas in multi-mode fiber, multiple rays can travel or multiple wavelengths can travel. Then based on refractive index profile, as we can use either glass or plastic material for core and cladding, so that material has some refractive index. So whether the refractive index profile is step index or graded index, based on that again they are divided. Here you can see this is a single mode fiber. In this single mode fiber, you can see only one ray of light is traveling, or we can say only one wavelength can travel at a time, and that is why name is given as single mode fiber. At the same time, you can also notice the core diameter is very narrow. Here you can see core is very narrow, and that is why we need laser as a source. We need coherent light or directed light. Whereas in case of multi-mode fiber, here you can see multiple wavelengths are traveling at a time, and that is why name is given as multi-mode fiber. Here losses are less in single mode fiber, no intermodal dispersion, whereas here intermodal dispersion occurs. Losses are more as compared to single mode fiber. Another thing is, in multi-mode fiber, we can send multiple wavelengths at a time. So we can use LED as a source. Lasers are also allowed, LEDs are also allowed. So these are types of optical fibers based on operating modes. It means how many wavelengths we can send simultaneously. Now let's differentiate single mode and multi-mode fiber. Here SMSI stands for single mode step index fiber and MMSI stands for multi-mode step index fiber. In next slide we will discuss about the step index fiber and the graded index fiber. So this is about step index only, and single mode and multi mode. So single mode fiber carries single mode of light or single wavelength. They carries multiple modes of light, multi mode fiber. They are used for long distance transmission because losses are less, so signal can travel longer distance. Whereas in multi mode fiber they are used for comparatively shorter distance. They have smaller core diameter as discussed earlier. Difficult to couple signal. So it is very difficult to enter light into those fibers because diameter is very narrow. Whereas in case of multimode fiber, the core diameter is large and that is why easy to couple the signal. Here in single mode fiber, less degradation of signals, less attenuation, no intermodal dispersion because single mode is present, so there is no intermodal dispersion. Whereas in multi-mode fiber, more degradation of signals, high attenuation. Of course, this attenuation is much less than other wired communication. But here we are comparing multimode fiber with single mode fiber only. So here attenuation is more, intermodal dispersion is also present. They are high speed, they are relatively slower. Here we use laser as a light source, and here we can use LED. Sometimes we also use laser. Then your bandwidth is very high in case of single mode fiber, whereas bandwidth is lower as compared to single mode fiber. Here higher electronic cost, and here in multi-mode fiber lower electronic cost, because here the core diameter is very narrow, so coupling is quite difficult, and that is why electronic cost is high. Then single mode fibers are used in telecommunication, they are used in Cat5 networks, and multi-mode fibers are used in security systems, they are also used in local area networks. So this is difference between single mode fiber and multi-mode fiber. It means how many wavelengths can travel parallelly. Now let's discuss types of fibers based on refractive index profile. So again they are divided as single mode step index and multi mode step index fibers. So here you can see first two diagrams indicates, see this is the representation of our optical fiber. So this is our core and this is our cladding. Core and cladding. Here this is core and this is cladding. You can see two types are step index. Step index means there is a step change in refractive index of core and cladding. So refractive index of core is constant, and the change, and then there is abrupt or sudden change in refractive index of cladding. Here also refractive index of core is constant, and then step change or abrupt change is present. But here, so this is step index fiber, this is also step index fiber, and then comes graded index fiber. In case of graded index fiber, you can see refractive index of core is not constant. It is maximum at the axis of the fiber, or at the center it is maximum, and then it reduces gradually towards the cladding. So here you can see it is maximum at the center and then it reduces gradually. Here 2A indicates diameter of the fiber. A is the radius of the fiber. So you can see, let's discuss about step index fibers first. So in single mode fiber, as discussed in previous slides, the diameter is narrow. So here diameter is around 8 to 12 micrometer, whereas this is again our step index only, but multiple rays can travel. So diameter is 50 to 200 micrometers. Diameter is more than that of step index. So these two are step index fibers. Only one is single mode, another one is multi mode. Then comes graded index fiber. In graded index fiber there is no single mode fiber, they are only multi mode fibers. The difference is because the refractive index is not constant, because the refractive index is not constant, so at the center straight axial ray can travel, but here they are not as straight. Here you can see the rays are straight, but here they are not straight, rather you can see they bend at the core cladding interference, or sometimes even you can see the shape is quite similar to our sine waveform. So that is difference between step index and graded index. Advantages of graded index fiber are the losses are less and they can travel more distance as compared to step index fiber. And here losses are less because there is less intermodal dispersion, there is less attenuation in graded index fiber. So optical fibers are divided into two types based on the refractive index profile, step index or graded index. Step index is step change in core refractive index and cladding refractive index. Graded index is the refractive index of core is not constant. Then again there are two types based on how many wavelengths can travel parallelly, and those types are single mode fiber and multi-mode fibers. So it was all about types of optical fibers. If you found this video useful, please like, share it with your friends and subscribe to my channel. Thank you so much for watching.